So in the previous two videos, we have talked about definition and value of a function. In this one, I'm going to talk to you about intervals. Now the transition is not very apparently, visible that we are talking about intervals all of a sudden. But let me tell you, for the next few concepts, this is going to be very important. And in general, in mathematics, this is very, crucial that you represent a set properly. So let's get started with the notations and basic things about intervals. So suppose I'm just saying that this is how we are representing an inequality. So what does it mean? It means that x can take any value between 0 and 1, including 0 as well as 1. So this is what an interval basically is. So suppose let's take this inequality. We say that x belongs to this interval 0 to 3. Now how do we represent it? Look at the number line. This is from 0 to 3. Now the 0 is included because if you look at the original inequality, there is no strict sign, 0 is getting included, so this is closed. And also if you look at 3, this is open, so there's a hollow space. If you remember our previous video, we have also included the value of a function by this hollow or closed thing, so that you actually know which value is included or not. Now that you see that there can be open intervals or closed intervals, we will actually talk about some basic things here. So I'm going to start with some basic things which are important to understand the picture, interval notations, their set builder form, and the description. So start with this one. So if you see interval of this form, this is actually an open interval. So this is the set builder notation. The inequality is it's between A and B. A is not included, B is not included. Now this is a closed interval. The set builder notation suggests that we include the extremities as well. So A and B, definitely they are there along with the values between A and B. This one, it's a semi-open or semi-closed interval. So A is included and B is not included. The last one, here you can see that A is not included, but B is included. So you don't have to memorize all of them. Just remember that if you have this enclosed, you have a closed bracket, which is normally the third bracket we use. Otherwise, it's open, so we don't include it. So you can construct the interval accordingly and also switch to inequalities or intervals as you need. So see some examples here. Look at the first one. This is closed interval 1, 2. So 1 and 2 both are included. In this one, we don't have any inclusion at all. In the third one, we have 1 included, whereas 2 is not included. And in the final one, 1 is not included, but 2 is included. And also we have written down the corresponding inequalities. So I hope you understand whenever you see any form, you know how to represent the same thing in the other forms as well. Now here's one thing which is very important, which is intervals to infinity. Till now we are talking about numbers which are lying between two finite numbers like 1 and 2 or maybe 0 and 3, etc. But we can have intervals to infinity as well. So let's get started with a very basic thing here, which is an inequality. X is greater than or equal to 1. So if you think about the number line, you can actually start from 1 and just go to your right as many times as you want to. So definitely we can say that from 1 we are going to the right and it can get as big as it wants and it's going towards infinity. Now we have included this 1 because there's a closed bracket, and also if you look at the original inequation, it has inequality, but never use the third bracket or the closed bracket for infinity. This is a very general notation that we use because there's no enclosure of this particular thing, which is a concept which is of infinity, so we don't include that. Similarly, if you talk about this one, you will understand that this is the general thing. So from A, we can go to the right as many steps as we want to. So this is A to infinity, and here we have closed bracket A to infinity because we're including A. So if you look at this one, this is hollow, whereas this is closed. So this will actually represent whether you are including A or not. Similarly, as we have moved on to the right side as we wanted to and get bigger values, we can also move on to the left side. So this is less than A. So go to the left as much as possible, and you are actually approaching a number which is negative, very, very small number, which is minus infinity. Now, in the first one, a is not included, whereas in the second one, a is definitely included. So I hope you understand the concepts of intervals. Now, let's see some examples so that you understand how we can write down some basic cell builder forms in terms of this. Non-positive real numbers. So you get all the possible values which are either 0 or negative. So that is why 0 is included. But if I talk about non-negative, you will actually include 0 as well as all the possible positive real numbers. Positive ones, as you can clearly see, we have only included the positive ones but not the 0 thing. Similarly, for negative, there's a strict inequality going on, and from the entire real number we have minus infinity to infinity. So remember that interval is nothing but a subset of the real line. So these are very important for representing different sets. So let's get comfortable with this idea and also see how we can represent it in different form. In the next concept, when we are going to talk about domain and range, it's going to be very important. So learn them and stay tuned for our next lesson.